When we think about for force, students net. Okay, the net force required students for a body performing circular motion. And when you consider for non-UCM students, there are two forces, force radial and force tangential students. And if I want to find out the net force, it will be under root, the magnitude of net force will be under root force radial the whole square, plus 4 tangential the whole square, students. Okay, students, now we move further ahead. So as if in short, suppose agar main just last derivation, if I happen to pick up again, students, in short, I'm trying to put forward, students. Since you know that theta is equal to, students, length of arc upon unit radius. Okay, students, in short, I'm trying to put forward. So length of arc is equal to theta cross r, students, in vector form, anti-clockwise direction.
Yes, sir.
If I differentiate both sides with respect to time, so ds by dt will be equal to d theta by dt cross r we consider. ds by dt will be v omega cross r. Do keep this in mind, students. Okay. Now, if I say UCM, students, UCM में क्या हो रहा है? Uniform circular motion में the body covers equal angle and equal interval of time. So students, ये ध्यान में रखना that for uniform circular motion, students, for uniform circular motion, I get it. Omega will be simply what? Omega will be simply equal to 2 pi by t or 2 pi f. ये ध्यान में रखना, students. Omega is called as what, students? What is omega is called? Can anybody tell me what is the name given to omega? Students, what is
Angular
omega called?
velocity.
Very good. It's called as angular velocity. Angular velocity. T is a time period. Students, frequency is always in hertz. और इसका जो यूनिट होगा वो किस में होगा? Radian second inverse. ये ध्यान में रखना. Do keep this in mind. For UCM. If in case if I speak about for non-UCM students, ये भी ध्यान में रखना. For non-UCM students, the body covers unequal angle, students, an equal interval of time, students. It covers unequal theta, an equal interval of time we consider. So यहाँ पे students for non-UCM omega को कैसे लिखोगे students? It's d theta by dt. Agreed? That means this is final angular velocity minus initial upon final time minus initial time. And this answer also is in radian second inverse. क्या ये clear हुआ students? Agreed? Students, क्या ये दोनों point clear है? All of y'all? UCM and non-UCM?
Can you explain again for non-UCM?
Non-uniform circular motion with the body covers unequal angle, na d theta by dt is omega. Rate of change of angular displacement with respect to time. The
Okay.
body covers unequal angle all the time. तभी जाके d theta by dt लिखते हैं. स्टूडेंट्स, इसका मतलब क्या मालूम है? लीनियर मोशन में तुम क्या समझते हो स्टूडेंट्स? अगर मैंने गाड़ी को शुरू किया पॉइंट ए में, स्टूडेंट्स ध्यान से देखो, पहले 10 सेकंड में उसकी स्पीड थी 10 मीटर पर सेकंड. दूसरे 10 सेकंड में उसकी स्पीड थी 25 मीटर पर सेकंड. तीसरे 10 सेकंड में उसकी स्पीड थी 5 मीटर पर सेकंड. चौथे 10 सेकंड में उसकी स्पीड थी 38 मीटर पर सेकंड. तो इज द स्पीड रिमेनिंग कांस्टेंट?
No, sir.
तो यहाँ पे क्या होगा? इज वेलोसिटी कांस्टेंट? नो. तो एक्सेलरेशन को कैसे लिखोगे? dv by dt लिखोगे ना.
Yes, sir.
That's how we consider rate of change of velocity. अगर मुझे velocity लिखना है तो मैं कैसे लिखूंगा? Rate at which displacement takes place, ds by dt. If I say that, अगर ये velocity की जगह पे मैंने suppose distance लिखा होगा, it covers 10 meters, then it covers 25 meters, 5 meters, so it will be ds by dt. Are you getting it?
Yes, sir.
अगर velocity constant होता, students, अगर velocity constant तो acceleration क्या बन जाता? Zero बन जाता. आया ना?
Yes, sir.
Excuse me, sir.
Yeah.
Sir, for the UCM, you've written angular velocity is equal to?
2 pi by d.
Okay,
2
sir.
pi by d. Or 2 pi. Frequency is reciprocal of time, students. ये पार्ट तुम लोग ने किया है in sound also. How is frequency defined as students? How is frequency defined as? Reciprocal of time. Students, किया कि नहीं किया 10th standard
Yes,
में
sir. Yes, sir.
हाँ. Frequency is defined as reciprocal of time, and reciprocal of time we consider frequency measured in hertz. तो स्टूडेंट्स ये जो तुम्हारा है ये ओमेगा इज इक्वल टू 2 पाई बाई टी है, ये नॉन यूसीएम है. अब यहाँ पे देखो स्टूडेंट्स, अगर ओमेगा इज 2 पाई बाई टी तो ओमेगा कांस्टेंट है स्टूडेंट, तो वहां पे क्या होगा, अल्फा 0 होगा. स्टूडेंट्स नॉन यूनिफॉर्म सर्कुलर मोशन, सॉरी यूनिफॉर्म सर्कुलर मोशन में स्टूडेंट्स अल्फा हमेशा 0 होगा, एक्सेलरेशन टैंजेंशियल हमेशा 0 होगा. यहाँ पे सिर्फ एक्सेलरेशन सेंट्रीपेटल ही होगा, फोर्स सेंट्रीपेटल ही होगा स्टूडेंट्स, ये ध्यान में रखना. लेकिन यहाँ पे नॉन यूनिफॉर्म सर्कुलर मोशन में ओमेगा is not equal to constant students, therefore alpha होगा. What is alpha? Rate of change of angular velocity. So can I say this is omega 2 minus omega 1 on t2 minus t1, है ना, change. जैसे मैंने अभी बताया ना, a is equal to dv by dt, final velocity minus initial velocity, final time upon initial time. स्टूडेंट्स क्या ये फॉर्मूला क्लियर हुआ सबको, अल्फा का फॉर्मूला?
Yes.
हाँ स्टूडेंट, अगर मैंने ओमेगा लिखा, व्हाट इज ओमेगा, ओमेगा इज 2 पाई एफ, तो क्या मेरा इसको ऐसे लिख सकता हूँ स्टूडेंट्स? Can I run this as the answer देखना स्टूडेंट्स, 2 pi f2 minus f1 upon t2 minus t1. क्या ये क्लियर हुआ स्टूडेंट्स? Omega is what? 2 pi f.
Yes, sir.
And the frequency is changing. Students,
Yes,
ध्यान
sir.
से सुनिए, listen carefully students. Last lecture में मैंने यहाँ तक किया था. You can't expect that a person should throw all the concepts at one time. Gradually, you need to absorb it. So that is said that if in case if things have been told to you, you might go through it, you might revise it, then you sit back to your lectures. Now, when a student knows it, that in non-UCM, omega is not constant, so alpha can be written as d omega by dt. What does that mean? Final minus initial, so to minus of तो हम अगर तुम्हें problems मिलेंगे तो ऐसे फॉर्म में भी मिलेंगे students. तभी भूल मत जाना कि how to solve it. वो जानबूझ के देंगे students, ध्यान से सुनना. Rakshit, F stands for frequency, my dear. I told you very clearly. Frequency is reciprocal of time period. Time period is always in seconds. Frequency is always in hertz. Students, they might say that a body is performing circular motion. Not just a body is performing circular motion, and the frequency is 20 revolutions per second. Are you getting it? It performs 20 revolutions per second in time 10 seconds. And then in the next time of 20 seconds, it performs 50 revolutions per second. तो तुम्हारा ये F1 हुआ, ये F2 हुआ, ये T1 हुआ, ये T2 हुआ. Can't you find out omega 2 minus omega 1? Yes. 2 pi constant निकाल दी. क्या ये क्लियर हुआ स्टूडेंट्स?
Yes, sir.
Sir,
Clear.
sir, but why are we not taking 2 pi r, the radius?
My dear, is omega distance or omega is velocity?
You guys velocity.
Now got it? है ना? That is radians per second. Gauri got it?
Sir, I didn't get it.
My dear, in the last lecture itself only I gave you linear term and angular term. What is V stands for? Gauri, what does V stands for?
Velocity.
What is the unit of velocity?
Meter per second.
What does S stands for?
Displacement.
What is the unit?
Meter.
It can be displacement or distance, velocity or speed. Okay, what does theta stands for?
angular displacement.
Why you said angular displacement? What made you to say that? From where? कहाँ से तूने पढ़ा ये? अपने आप से कुछ भी बोलोगे?
Sir, it is
हाँ?
angular displacement.
Why? कहाँ पे पढ़ा तुमने? Where have you learned? Where have you learned? बोलो.
Sir, like आपने कल बताया था कि theta is angular displacement.
मैंने तो बताया था, लेकिन गौरी मैथ्स में नहीं पढ़ा था प्लेन एंगल. हाँ, थीटा, रेडियंस, मैथ्स भूल गए?
No.
नहीं, मैथ्स भूल गए. मैथ्स भूल गए, फिजिक्स में याद रखा. हाँ, वहां पे भी तो कोऑर्डिनेट ज्योमेट्री के अंदर है. जब भी तुम्हें कार्टेशियन साइन कन्वेंशंस के हिसाब से तुम्हें कार्टेशियन कोऑर्डिनेट एक्सिस के बारे में बोला था. तो अगर तुम्हें ग्राफिकल रिप्रेजेंटेशन कहाँ पे दिया होगा, तो कहाँ पे तुम्हें एंगल मेजर करने के लिए होगा, तो वो थीटा बोलते हैं ना वहाँ पे, है ना?
Sir, I thought you were asking physics like that.
No. But you know it. See, one thing, I'm not trying to put forward my own words. I told you by analog. By analog, since it's linear, this is angular. So of course there are, and now if I say this is theta, this is also theta. If I say this is theta 1, and if I say theta 1 is equal to theta 2 is equal to theta 3, and if the distance is same, then what is the path? Circular only, na?
Rectangle.
गौरी क्लियर हुआ?
नहीं.
Yes, sir.
तो ये मीटर में है, ये रेडियन में है. अभी ये लीनियर वेलोसिटी है,
नहीं.
speed है. तो what is omega? What is omega over here?
ओमेगा पता नहीं.
Hello, Chuhi.
Yes, baby.
Chuhi,
Yes, baby.
how are you, Chuhi?
Fine.
You're fine, Chuhi?
Yes.
Very good. And where do you stay, Chuhi?
Yes.
Chuhi, where do you stay?
What happened, sir?
Where do you stay, Chuhi?
Sorry.
Yes. Very good. You're so cute, Chuhi. Okay?
Thank you.
Nice. Got it, students? Saw the elements? Anna? Students, you'll see what kind of elements come into the lectures. Zia? Suna, Zia? Zia? Was it your friend? Zia, was it your friend?
No.
Okay. Did you got it? Who was it?
No.
Okay, I came to know about the name. And it's already gone to the head. And Shreya, Shreya, are you there, Shreya?
Yes, sir.
Okay. You thought so, sir is chatting with that person, isn't it? You know?
No, sir. I was thinking of telling because the mic was on and the roll number looked
No
so
need
weird.
to say. I was deliberately speaking to that person for certain longer time to identify who's a person. If the person conversates with a person for more than 7-8 seconds, it goes beyond certain time, you can come to know who's that person. So I was deliberately trying to speak in such a way. Okay, so that is what I saw your message, but I didn't reply it. Okay, Shreya. Okay, Gauri, are you there, Gauri?
Yes, sir.
अब मुझे बताओ ये थीटा रेडियंस में है, तो ये ओमेगा क्या होगा, किसमें होगा? ओमेगा इज व्हाट? d theta by dt.
Yes, sir.
And that is रेडियन पर सेकंड की वेलोसिटी हो जाएगा.
Yes,
हाँ,
sir.
तो कहाँ से तुमने यहाँ पे क्या बोला था इसको? तुमने यहाँ पे क्या बोला था? 2 पाई v क्यों नहीं लिखा है ना?
Sir,
Yeah,
no,
sorry,
sir,
2 pi.
that is not my doubt.
You said it na 2 pi r. You said it.
So no, actually, for the above line where you've written for UCM and angular velocity is equal to 2 pi by t. So over there, why haven't we included r 2 pi r by t? That is my doubt.
My dear, if I would have written 2 pi r by t, then that becomes distance upon time. Distance upon time, and that distance upon time is speed. Gauri, if I make you to Gauri, you are starting from point A. You run a 400-meter race. You run all the way and you come back to the same point. So किसी ने पूछा, what is the distance covered by you? Won't you say equal to circumference?
Yes, sir.
And what is the time taken t? तो क्या होगा? वो speed होगा ना?
Yes, sir. Got it.
Students, one thing, if you are, it's not that, I don't know about it, how many of you all had referred the previous sessions? अगर तुमने ध्यान से previous sessions को वापस refer किया होगा या देखा होगा या notes maintain करके रखी होगी, things should be very, very clear by this time that when you're speaking about for circular motion, students, for uniform circular motion, we say that the body covers equal angle and equal interval of time. So omega can never be written as d theta by dt. Omega is simply theta by t. Therefore, can be written as 2 pi by capital T or 2 pi f, which are made it very clear. And omega is in radian per second. Since omega is constant, therefore alpha वहाँ पे हमेशा 0 होगा. तब जाके tangential acceleration भी 0 होता है. तब जाके UCM में सिर्फ एक ही acceleration होता है radial. एक ही force होता है radial. That is centripetal force. बस. लेकिन जब तुम नॉन यूसीएम में जाते हो तो वहां पे तुम्हारा ओमेगा कांस्टेंट नहीं है, तुम्हें चेंज इन एंगुलर डिस्प्लेसमेंट अपॉन चेंज इन टाइम आएगा. तभी जाके जैसे थीटा 2 माइनस थीटा 1 अपॉन t2 माइनस t1. अभी जहाँ चाहो तो मैं थीटा भी चेंज कर सकता हूँ स्टूडेंट्स. I will also write on this omega as students. I will also write on this omega as आंसर सुनना, theta 2 minus theta 1 upon t2 minus t1 will be equal to what? बताओ, क्या ये करेक्ट है? Is this formula correct for non-UCM? Students, this is for non-UCM because omega is d theta by dt. Students, for non-uniform circular motion, omega is d theta by dt. Is this correct? Anyone? No, students? Yes, anyone of you all?
So what is n in the formula?
N is a number of rotations, a number of revolutions. Number of revolutions. Come on, Yash. Answer. Yash, 21, 89, 86. Vadim, Sujit, Shibam, Shrina, Sakshi, what about you? And Rishi, yesterday last lecture you left early. Many students left early. Rishi, why did you left early? Rishi? Rishi,
Yes, sir. My net was working proper, sir.
last half an hour you're not there. Even Meenu. Meenu, what about Meenu? Meenu, unmute yourself. Even you were not there also in the lectures. Why do you all try to enter right now then? You should be away from the lectures. No need to enter at all. Meenu, unmute yourself. Otherwise, I'm going to remove you from the lectures. Reply. Meenu, it seems that you're not in the lectures. Who said it? Your mic is working. I could see over here the mic is properly working. And why did you leave for last 10 minutes? Last 30 minutes. Why you were not there in the lectures? Is your parents knowing about that? Call your mom. I want tell your mom to text right now. Tell your dad to text right now, and I'll ask him whether mic is working or not working. Last 30 minutes, why you were not there in the lectures? Previous ones. Yes, I'm asking you, maybe something. Last 30 minutes, you were not there in the lectures. I want to know it from your parents. I'm waiting. Your phone got switched off. So your parents might be knowing it, isn't it? So that's what I
Hello.
want to know it from them. I want to know it from them.
Hello. Good evening, sir.
Yes, good evening.
सर मैं यश का पेरेंट्स बोल रहा, बड़ा भाई बोल रहा उसका.
Yeah, Yash. Who's this Yash? Which branch?
पीपी भाटिया.
हाँ बोलिए. Yes.
सर उसकी तबीयत खराब है थोड़ी सी.
Okay, fine. तो lectures में है यश. यश
वो
तो खारघर का है ना. There are two students from खारघर. टीपी भाटिया का यश तो है ही नहीं यहाँ पे. अच्छा एब्सेंट है आज.
सर एब्सेंट है वो. रुको मैं कॉल करके देखता हूँ उसको.
Okay, fine.
सर ऐसे ही वो लेक्चर बैठता नहीं है क्या?
That you can speak out to the office, okay? Already things have been told, okay? That you don't worry about it, okay? Office से बात करिए.
ओके.
Okay? Yeah. Now, students, are you there, students? Can you hear me?
Yes, sir.
Okay. Okay, students. Now, when you're speaking about with respect to circular motion, students, your omega is d theta by dt. N stands for number of rotations, students. Number of rotations. मैंने पूछा क्या ये correct है relation, students? Is this a correct relation? Tell me that. Now, students. Yes, anyone? Remind you, students, this is not physics, it's maths. Students, can you give me a relation of theta with number of rotations? Why not? Students, if you try to complete one revolution, put n equal to 1. So theta is given as by what formula? Theta is given by the formula n into 2 pi. Students, अभी ध्यान से सुनना. अगर तुम पॉइंट A से शुरू करते हो और तुम पूरा एक revolution लेते हो, तो can you tell me one revolution, what is the angle traced by you? What is the angle traced by you? So 1 into 2 pi. So can I say my answer is 2 pi radians, which is equal to 360 degree. क्या ये clear हुआ? हाँ.
So
Students, are you
can you
getting it?
explain again?
if I go for 2 revolutions, Shreya, if you run a ground twice, if you run the ground twice, so what is the angle you have traced? 2 into 2 pi, 720 degrees. क्या ये रॉकेट साइंस रॉकेट्स मैथ्स है? स्टूडेंट्स, ये क्या रॉकेट है मैथ्स? इतना टफ लग रहा है समझने के लिए? ये सब मैथ्स का कंसेप्ट है स्टूडेंट्स, ये कुछ फिजिक्स का कंसेप्ट नहीं है. Shreya, is it clear?
Yes, sir, understood.
If I say that you have covered 10 rotations, स्टूडेंट्स अगर तुमने ग्राउंड का 10 ग्राउंड का तुमने पूरा सर्कुलर ग्राउंड का 10 राउंड मारे, तुमने कितना एंगल ट्रेस किया? ये तुम्हारे पापा ने तुम्हें क्वेश्चन पूछा, तो कैसे फाइंड आउट करोगे एंगल भाई? तो n into 2 pi नंबर ऑफ रेवोल्यूशंस 2 pi, खत्म हो गई बात. तो देखो ना, थीटा 2 माइनस थीटा 1 को कहना पुट रहा, 2 pi into माइनस 2.1, 2 pi को मैंने बाहर निकाल दिया. स्टूडेंट्स तुरंत अब्सॉर्ब करो, तुरंत you have to pick up. Again, I'm telling you very clearly, those who have gone through the previous lecture properly will be able to catch up more faster today. The 3 sessions are kept consecutively one after another, so that things becomes in rhythm. If you don't go through it, if you don't revise it, you are lost. क्योंकि और आगे बढ़ने वाले हैं आज हम और आगे जाने वाले. तो पहले मैंने तुम्हें ओमेगा तुम्हें दिया था in terms of 2 pi by t. That is, ये पता है, that is UCM. मैंने सिर्फ ये बोला था it covers equal angle in equal. अभी suppose मैंने बोला कि अगर if it covers equal angle in equal time, so let us say it covers 2 pi in time period t. If it covers equal angle, so let us say that it's covering 2 into 2 pi in time 2t, then equal time. If it covers 3 times 2 pi in times 3t, तो आंसर क्या होगा? ओमेगा 2 pi by t. That is always for UCM. What is reciprocal of time? Is equal to frequency. अभी देखो, आज मैंने फ्रीक्वेंसी भी डाल दिया. लास्ट टाइम मैंने बोला था, वो नहीं बोला था. क्यों नहीं बोला? क्योंकि एक ही टाइम पे सब कुछ नहीं बताया जाता, धीरे धीरे उसको ऑब्जॉर्व करते हैं. और तुम्हें पता होना चाहिए रेसिप्रोकल ऑफ टाइम इज कॉल्ड एज फ्रीक्वेंसी. हाँ सर, ये तो हम लोग ने पढ़ा है. फ्रीक्वेंसी इज नंबर ऑफ रोटेशंस, नंबर ऑफ. अगर किसी ने पूछा व्हाट इज द यूनिट ऑफ फ्रीक्वेंसी, स्टूडेंट्स बता सकते हो कोई फ्रीक्वेंसी का? स्टूडेंट्स, नंबर ऑफ रेवोल्यूशंस पर सेकंड, number of rotations per second, number of oscillations per second, number of cycles per second, number of ripples per second, or simply second inverse or hertz. ये सारे इसके यूनिट्स है. और ये सब कुछ स्कूल में पढ़े हो. नहीं पढ़ा तो तुम्हारा प्रॉब्लम कि तुमने नहीं पूछा, टीचर ने नहीं बताया, लेकिन ये था स्कूल में, ये 110% था. वापस बोल रहा हूँ, फ्रीक्वेंसी इज number of revolutions per second, rotations per second, ripples per second, oscillations per second, cycles per second, rotations per second, second inverse या simply hertz. तो है क्या? reciprocal of time. ये मैंने थीटा को कैसे लिखा? 2 pi n2 minus n1. तो जब भी थीटा अगर कांस्टेंट नहीं होगा, अगर थीटा कांस्टेंट नहीं है, इट कवर्स अनइक्वल थीटा एंड इक्वल टाइम, तो व्हाट एक्जेक्टली? ओमेगा इज आल्सो नॉट कांस्टेंट, दैट इज नॉन यूसीएम. अगर ओमेगा कांस्टेंट नहीं है तो अल्फा होगा. अगर अल्फा होगा तो टेंजेंशियल एक्सेलरेशन होगा. यानी यहाँ पे स्टूडेंट्स तुम्हें टेंजेंशियल एक्सेलरेशन भी मिलेगा, टेंजेंशियल फोर्स भी मिलेगा, लेकिन इसके अलावा तुम्हें एक्सेलरेशन सेंट्रीपिटल भी मिलेगा, फोर्स सेंट्रीपिटल भी मिलेगा. तो यहाँ पे 2 फोर्स 2 एक्सेलरेशन, यहाँ पे सिर्फ एक फोर्स और एक एक्सेलरेशन, दैट इज एक्सेलरेशन सेंट्रीपिटल एंड फोर्स सेंट्रीपिटल. Students, is it clear to all of you all?
Yes, sir.
Okay. So I was just trying to brief up the previous part of it. Students, that's how I've written this. Now let me go back to what exactly I was speaking about. Since we know that S is equal to theta cross r differentiating both the sides, I got this part of it, and this is incorrect in vector notations. तुम्हें ये भी क्लियरली पता होना चाहिए कि अगर एक्स वाई प्लेन में लिया तो एक्स एक्सिस पे कौन से टर्म्स है, वाई एक्सिस पे कौन से, जेड एक्सिस पे कौन से, IJK में ये भी मैंने बताया था। अब आज पता चलेगा ना, अभी मैं इसके बारे में क्वेश्चंस पूछने वाला हूँ मैं, पता चलेगा कितने जन रेफर करके बैठे हुए हैं, कितने जन को आता है और कितनों ने लर्न करके बैठा हुआ, तुरंत आंसर देंगे। और जिसने नहीं पढ़ा है, उसके ऊपर नहीं सोचा, दे विल बी कंप्लीटली ब्लॉक्ड, दे विल नॉट बी एबल टू गिव अ सिंगल आंसर। आई एम टेलिंग यू वेरी क्लियरली ऑन योर फेस। Those who have learned it properly or those who have gone through it will certainly get it. Now suppose अगर मैं इसको डिफरेंशिएट करता तो मैंने यहाँ पे क्या किया था सर, आपने यहाँ पे प्रोडक्ट रूल ले लिया था, तो व्हाट एग्जैक्टली इट्स dv by dt इज इक्वल टू, अगर मैं ओमेगा को कांस्टेंट रख सकता हूँ, मैंने डिफरेंशिएट किया था dr by dt प्लस फिर मैंने ओमेगा को डिफरेंशिएट किया है, r को कांस्टेंट रखा है। अगर ध्यान से सुनना, अगर मैंने ओमेगा को कांस्टेंट रखा, स्टूडेंट्स मुझे बताओ ओमेगा कहाँ पे कांस्टेंट है, तो बोला सर नॉन यूसीएम में नहीं, यूसीएम में ओमेगा कांस्टेंट, यूसीएम में ओमेगा कांस्टेंट है। यानी ये कंसेप्ट मोर प्रिसाइजली किसके ऊपर जाएगा, एक्सेलरेशन सेंट्रीपिटल के ऊपर जाएगा। और यहाँ पे ओमेगा चेंज हो रहा है, डी ओमेगा बाई डी टी, जहां पे डी ओमेगा बाई डी टी आएगा वहां पे अल्फा आएगा, और ये किसके लिए जाएगा, टेंजेंशियल के लिए जाएगा। तो व्हाट एग्जैक्टली व्हाट इज डी वाई बाई डी टी इज कॉल्ड, सर दिस इज कॉल्ड एज नेट एक्सेलरेशन। ये होगा ओमेगा, ये होगा वेलोसिटी, because the position vector changes with respect to time, that give me change in velocity, direction of velocity goes on changing because of the change in the direction of position vector। जिस डायरेक्शन में position vector होगा, velocity उसके डायरेक्शन में परपेंडिकुलर हो जाएगा। देखो पोजीशन वेक्टर का डायरेक्शन चेंज होता है तो डायरेक्शन ऑफ वेलोसिटी आल्सो विल चेंज, पोजीशन वेक्टर का डायरेक्शन चेंज होगा, वेलोसिटी का डायरेक्शन भी होता है, इसलिए dr by dt को मैंने भी लिखा है, प्लस डी ओमेगा बाई dt को क्या लिखोगे, अल्फा क्रॉस r। ये क्या होगा सर, एक्सेलरेशन सेंट्रीपिटल, क्या मैं उसको रेडियल एक्सेलरेशन में बोल सकता हूँ, क्यों नहीं, प्लस ये क्या होगा, एक्सेलरेशन टेंजेंशियल। ये क्या हुआ तुम्हारा सर, ये हमारा नेट एक्सेलरेशन हुआ। यानी अगर कोई बॉडी नॉन यूनिफॉर्म सर्कुलर मोशन करता है तो कितना एक्सेलरेशन है सर, उसको 2 एक्सेलरेशन है। You have 2 acceleration students. Which are the 2 acceleration we consider? One of them is called as acceleration tangential, and the other one is called as acceleration centripetal. इनका रिजल्टेंट फाइंड आउट कर सकते हो? हाँ सर, इनका रिजल्टेंट ये अगर मैं वेक्टर को यहाँ पे शिफ्ट कर दूं, टेल है तो रिजल्टेंट इस तरफ जाएगा, ये हुआ मेरा एक्सेलरेशन नेट। So for non-UCM, you have 2 acceleration. Correspondingly, 2 forces, force centripetal, force tangential, therefore this becomes force net. Okay, मैंने पूछा students, what is the direction of resultant? So let us say this is direction. So what exactly? Tan phi opposite tangential upon adjacent. So what exactly phi will be? Tan inverse of acceleration tangential upon acceleration radial. What is the formula for acceleration tangential? Friends, what is the formula for acceleration tangential? What is the formula for acceleration tangential? Alpha into r. What is the formula for radial acceleration?
Omega into v.
यानी जब तुम सॉल्व करो तो ये वैल्यूज तुम्हें देंगे, फिर आगे आंसर तुम्हारा। Is this part clear to all of you?
Yes, sir.
Gauri, is it clear to you now?
Yes, sir.
Shreya, what about you? Shreya, clear?
Yes, sir.
श्रेया, कुछ भी डाउट हो बिंदास पूछो, नथिंग टू वरी अबाउट इट स्टूडेंट्स। अगर सीरियसली होगा तो पूछो, आई एम रेडी टू एक्सप्लेन यू 10 टाइम्स, लेकिन क्लियर करो। और तुम्हें ये बेनिफिट होना चाहिए कि चलो ये लेक्चर्स 3 लेक्चर्स कंसेक्यूटिव है, आई गेटिंग इट, इट शुड बी रियली एन एडवांटेज, क्योंकि कंसेप्ट तुम्हारे एकदम आगे आगे और कंसेक्यूटिवली हो रहा है। ऐसा नहीं कि एक लेक्चर हुआ उसके बाद में 8 दिन का गैप हुआ फिर वापस तुम बैठो तो पीछे का याद नहीं रहता है, लेकिन अगर तुम इसको पढ़ोगे तो सही तरीके से होगा। Now can I erase the students? इसको erase कर दोगे मैं? हाँ students?
No, sir. One.
यहाँ से लास्ट टाइम से students मैंने नया चीज क्या बताया यहाँ पे? What is extra which I told you? I only told you that omega can be 2 pi by t or 2 pi f. That is for UCM. F stands for frequency and T stands for time period. Frequency के अलग-अलग units दे दिए मैंने. RPS, OPS, CPS, S inverse, hertz. यानी जब भी तुम प्रॉब्लम रीड करो तो सोच समझ के रीड करना क्या दिया है. दूसरी बात, नॉन यूसीएम के अंदर तुम्हारा ओमेगा मैंने सिर्फ डी थीटा बाई डी टी लिखा था, लेकिन आज मैंने उसको और अलग तरीके से लिखा, थीटा 2 माइनस थीटा 1. उसको वापस तुम लिख सकते हो n इंटू 2 पाई में. मैंने बताया था n इंटू 2 पाई बाहर निकाल लिया था, n2 माइनस n1 लिया था. वैसे ही अल्फा को मैंने सिर्फ ये बताया था, अभी मैंने ओमेगा 2 माइनस ओमेगा 1 लिखा है और ओमेगा का फॉर्मूला 2 पाई एफ है. ये आंसर किसमें होगा? ये आंसर किसमें होगा सर? ओमेगा इज रेडियन पर सेकंड. ये आंसर रेडियन सेकंड इनवर्स, सेकंड स्क्वायर इनवर्स. The rest everything I did it earlier also. Done, students?
Yes.
Okay, students. Students, put down a question. Let's see who can get the answer. Okay, students, listen carefully. Students, a body is performing circular motion with constant angular acceleration. Okay. Performs circular motion with constant angular acceleration, students. Alpha is constant. Okay. In time t1, it covers an angular displacement theta 1. Okay. In time t2, it covers an angular displacement of theta 2. So the question asked is find out the ratio of change in angular displacement. Find out the ratio of change in angular displacement with respect to initial angular displacement. Is the question clear? Find out. Friends, is it clear?
Yes.
Students, I made it very clear that a particle is performing, a particle is performing circular motion, students, with angular acceleration to remain constant. Okay. And initially it starts from rest. Let us say that the particle initially starts from rest. Initially starts from rest. So a particle is performing circular motion initially at rest, then attains a constant angular acceleration. It covers angular displacement theta 1 in time t1, theta 2 in time t2. I need to find out, students, the ratio of change in angular displacement with respect to initial angular displacement, students. Is this question clear to all of you all?
Yes.
Students?
Yes, sir.
A particle is performing circular motion initially at rest. It moves with constant angular acceleration. It covers an angular displacement of θ1 in time t1 and θ2 in time t2. Find out the ratio of change in angular displacement with respect to initial angular displacement. Menu, are you there in lectures or you're not there in the lectures? You're not replying at all. So I've texted you, which branch are you into? And what's your roll number? I want to know it right now. I'll tell the concerned person to call up your dad. Tell me which branch and what's your roll number. Text it to me directly. I'm asking you since when? Okay. Roll number? Yes, anybody can get the answer, students? Fast. Can I solve it for you all, students? Can I solve it?
Yes. Yes.
क्यों नहीं आ रहा है? Alpha constant है. It covers θ1 in time t1, θ2 in time t2. Initially, the body starts change. So can I find out the value of θ1? Yes, sir. Simply using the formula theta is equal to omega naught t plus half into alpha into t square. Students, ये equation नहीं दिया था मैंने? हाँ, students?
Yes. Sir.
Circular kinematics clear? So let us say that the theta in the θ1, initial angular velocity is 0 into t1 plus half into alpha into t1 square. Theta 2 is what? 0 into T2 plus half into alpha into T2 square. I want ratio of change. So theta 2 minus theta 1 upon initial theta 1. तो ये तो 0 हो जाएगा. यानी ये होगा सिर्फ हाफ अल्फा T1 स्क्वायर और ये होगा हाफ अल्फा T2 स्क्वायर. तो न्यूमरेटर क्या होगा? हाफ अल्फा T2 स्क्वायर minus half alpha T1 square upon क्या? What is theta 1? Half alpha T1 square. So what's your answer? Ratio of theta 2 minus theta 1 upon theta 1. Can I say half alpha will be outside? T2 square minus T1 square upon half alpha T1 square. Did you get it?
Yes, sir.
तो क्यों नहीं मिला? Why did you get it?
Sir, I got the same answer. I thought it would be some integer ratio. So
No, how many fellow got this answer? Raise your hand, students. How many fellow got this answer? How many students got it? Just me has got it. What about rest of them? Avneet, what about you? Gauri, what about you? Minu, what about you? You didn't get it, Minu. Yash, what about you? Zia, what about you? Shreya, what about you?
So
Zia,
I
why?
got both the equations, but then in the ratio part, I made a mistake.
Okay. And Zia, why did you get it, Zia? Zia, why did you get it? Zia, why did you get it? See, I asked so many times to Zia, but is she replying? Is she replying? No. This is what the problem with the students is. Okay, students. Now suppose if I try to give you a question, students. Okay, students, find out the ratio of, okay, students, listen carefully. Find out the ratio of angular displacement students, find out the ratio of angular displacement in third second of its motion to 1 second. Ratio of angular displacement in third second of its motion to 1 second for a body starting from rest. Students, for a body starting from rest with constant angular acceleration of 10 radian second square inverse. Can you get an answer, students?
yes, sir.
Rather than going for third second of its motion, students, you can go for second of its motion. Don't go for third. Second of its motion. Making it easier. Yes, Minu, you can. Minu, you can. Ratio of angular displacement in second of its motion to first second, students. Very good, Meenu. Now see. Shreya's got the answer. Anybody else? Zia,
Sir.
can you answer?
Sir, I messaged you the answer.
Yeah, I got it. Absolutely correct. Gauri has answered, Meer has answered, Shreya has answered. Three of them has answered. Zia, what is your answer, Zia? Zia, are you there? So students, can you tell me how to go about? Any of y'all?
Yes, sir.
Bolo.
Sir, we can use the formula of angular displacement at the nth second. Angular velocity, initial angular velocity plus alpha into n minus half.
Okay, so that is for second of its motion, isn't it? Yari, you can consider
Yes, sir.
plus alpha into bracket n minus half. And what exactly taking n is how much?
N will be 2 for second.
Okay, fine. Okay, then
Angular
and for
angular.
first case, what exactly be? Omega is 0 in that
Yes,
case.
sir.
Then second case के लिए?
Second case के लिए n will be 1.
No, but this is if in 1 second its motion to 1 second of its motion. So is it in 1 second? Or is it the first second of its motion? Over here, should I use n second ka formula or should I use omega naught t plus half alpha t square, students?
Yes, sir. Omega.
और अगर तुम
alpha.
1 minus अगर तुम 1 minus half लोगे तो half ही आएगा ना, आंसर वही आएगा तुम्हारा.
Yes, sir.
Same आएगा. So the answer will be equal to what? This will be alpha by 2. Agreed. And this will be how much? Numerator क्या होगा 2. So this will be how much? 3 alpha by 2. This is alpha by 2. Alpha by 2 will get cancelled. 3 upon 1.
Yes,
Is that
sir.
clear? And 3
Yes.
students have given the answer. Okay. Now, students, I want you to give me the correct vector notations. I repeat. Students, I want the correct vector notation for a body performing circular motion, students, where I'm giving you subject on the left-hand side and you have to match it up with the right-hand side, students. So the first is, listen carefully, students. If I give you linear displacement, position vector, and angular displacement, students. So I wanted to make S bar as a subject. I want my S bar in terms of R and theta. Agreed? For a body performing circular motion in anti-clockwise direction. Which direction, students? Anti-clockwise. I wanted to write on the correct vector relation. Second one, students. Second one, I wanted to give a relation between R bar, V bar, and omega bar. And students, V bar is a subject. So I want to write on the correct vector notation for this. Third one, I want to give you for position vector, angular acceleration, and tangential acceleration, students, and tangential acceleration is my subject. Write on in correct vector form. Fourth one, position vector, angular momentum, linear momentum. And students, I wanted to make angular momentum as my subject. Fifth one, position vector, tangential force, and moment of force. I want a correct vector relation for moment of force. क्या ये question clear हुआ students सबको? Students?
Yes, sir.
The particle is performing circular motion, anti-clockwise motion in XY plane. Are you getting it? I wanted to give you the correct vector notation in each case. Zia, are you there in the lectures?
Yes, sir.
Where are you? You were not there in the lectures for so long time.
I was
What are
there.
you doing? Huh?
I was there.
Not at all. So many times I've texted you, so many times. Students, how many times I've called her? Anybody can reply? Students, just reply to her. How many times I've called?
So more than 5 to 6 times.
And initially also, उसका उन्हें problem भी किया, वापस बोला है, text भी किया. If you want to be in the lectures, be into the lectures. Otherwise, get lost. Move out. No need to sit into the lectures.
Sir, laptop glitch हुआ तो फिर मैं क्या करती?
अरे laptop glitch हो गया तो you should have texted in that case because of that reason.
अरे but then how would I?
Can't you see the text for a long time?
Sir,
When you
text
come
ही
in
नहीं कर पा
also,
रही थी.
when you come in at the same time you're listening to me, so you should say, okay, sir, I was in that, and this is the problem, and this is the problem you're having in the last lecture also. It was the same.
Sir, अब अगर laptop glitch होगा, if even if I was able to see the text, मैं reply कैसे करती अगर mic भी unmute नहीं कर पा रही हो, text भी नहीं कर पा रही हो?
But this was a problem happening last time also. It's the same
Last
problem.
time तो नहीं हुआ था ये चीज. Last time
It
मेरी
was
mom का.
earlier also when you were not there in between the lectures.
No, last time I
Because
had taken my mom's
I called you
hotspot.
for a question. I had thrown a question and asked questions, so I called your name at that time.
When?
But this is what it is. I called it for that, and you didn't reply. Then again I texted. Give me the answer for the students now. Anyone who knows it, please raise your hand and give me the answer. One who knows the answer, raise your hand fast. Yes, anyone? Yes, me. What about you, Avneet? Carol, Gauri, Dhruv, Krisha, Meenu, Om Panchal. Prisha, what about you, Prisha? You're not answering at all. Shreya. सारों का माइक के साथ में प्रॉब्लम है. मिहिर, are you there, मिहिर?
Yes, sir.
सिर्फ आप लोगों का ही माइक सही चल रहा है. तेरा माइक सही चल रहा है, श्रेया का सही चल रहा है, गौरी का चल रहा है. बस तुम लोग तीन ही हो जिनका माइक सही है, बाकी सबका माइक वैसे ही प्रॉब्लम है. See? Don't worry. Now you come into the sessions at the lectures, because from Monday onwards your colleges are reopening. Okay? It doesn't matter, Prisha. And from Monday onwards your colleges are reopening. Then I'll be asking you within the lectures questions. Is anyone? Mihir, Gauri, Shreya, anyone?
Sir, can you please do the first part?
Bolo.
Sir, I'm saying, can you please do the first part?
ये तो वाला किया ना. देखो ना, एक्स वाई प्लेन मैंने क्या पूछा, मैंने वही चीज वापस पूछ रहा हूँ स्टूडेंट्स. ये देखो ना, बॉडी इज मूविंग इन एन एक्स वाई प्लेन. स्टूडेंट्स ये देखो, तुम्हारा एक्स एक्सिस है, ये वाई एक्सिस है. स्टूडेंट्स दिस इज एक्स एक्सिस, दिस इज वाई एक्सिस, एंड द बॉडी इज परफॉर्मिंग सर्कुलर मोशन इन एक्स वाई प्लेन. ये तुम्हारा जेड एक्सिस है. So these are the tangential terms. This is the radius vector we consider, and these are your angular terms. So students, didn't I tell you which terms are acting along I cap, which terms are along J cap, and which terms are along K cap? Students, ये बताया कि नहीं बताया students?
Yes,
Students?
sir.
तो ये सबको तो बताया था. Now using that, can't you get an answer? And I made it very clear. मैंने वही पूछा XY plane. अगर मैंने YZ चेंज किया होता तो तुम इतना सोचते ना. और अब भी हमने किया है, अब भी मैंने इसका डेरिवेशन दिया है. What is S bar? सर तुम बोलोगे, तुरंत बोलोगे सर S bar is along J cap. And if I happen to go for right hand screw rule, friends, if I happen to go for right hand screw rule, where I can say I, J, K. What is J? What is J? J
K
is
cross I.
equal to K cross I. तो क्यों इतना टाइम लग रहा है? क्या रॉकेट साइंस वापस पूछा?
No, sir.
This shows that you all haven't done the previous lecture. Students, I'm very sorry. I'm telling you very clearly on the face. We haven't gone through the previous session at all properly. उसको देखा भी नहीं और डायरेक्टली लेक्चर्स में आके बैठ गए तुम. So why should I speak? Why should I unnecessarily tell Meenu something? Why should I unnecessarily tell Prisha? Why should I unnecessarily tell Om? Why should I unnecessarily tell Zia? I'm sorry to all these students. Zia, I'm very sorry. Prisha, I'm very sorry. Om, I'm very sorry. Meenu, I'm very, very sorry. Meenu, to you also. Hello? I'm very sorry. Yeah.
Sir, now can you hear me?
Yeah, bolo. Prisha.
Yeah, sir. I was just checking is the mic working or not? Because I changed 3-4 headphones right now.
No, fine, Prisha. It's fine that your mic is working, but I'm not getting any answers from the students who are really answering. So it's not your fault, it's my fault. Okay, to all the students to whom I said it, why aren't you answering it? I'm very, very sorry. and it's going on recordings. No teacher will speak to you all like that. But this is very true. और ये कराया हुआ है. अगर सपोज मैंने चेंज किया होता YZ या ZX किया होता तो तुम सोचते ना कि यार ये तो चेंज कर दिया, सोचना पड़ रहा है हमें. इसमें सोचने की बात ही नहीं थी. एस बार यानी जे कैप क्या होता है? जे इसको के क्रॉस आई में के में क्या आ रहा है सर? के में थीटा आएगा, थीटा क्रॉस आर आ गया, खत्म हो गई बात. दूसरे केस में क्या आएगा? वी बार सर, वी बार इज अलोंग विच एक्सिस सर? वी बार इज अलोंग जे. सो व्हाट इज जे अगेन? के क्रॉस आई. के में क्या होगा? एंगुलर वेलोसिटी आर. फिर एक्सेलरेशन टेंजेंशियल. एक्सेलरेशन टेंजेंशियल कहाँ पे है? वापस जे. सो व्हाट इज जे? अगेन जे इज इक्वल टू के क्रॉस आई. सो इट्स अल्फा क्रॉस आर. हो गया. More Rakshit, no need. Rakshit, are you there, Rakshit? Can you unmute?
Yes, sir.
Yeah, because there are elements. There are elements who are trying to enter. Okay, there are certain students who are inside the lectures who are calling their elements also inside it. So that's why I've locked it. Okay.
Okay,
Listen
sir.
carefully.
Okay.
L bar. Okay. L bar in that case. Now for L bar we consider angular momentum, and once when you go, you are not able to come back. यानी तुम्हें जाना हो तो बिंदास जाओ. I get it. You will not be able to enter the meeting also.
No, sir.
Okay, angular momentum is L bar. Students, angular momentum is again which axis? It's K cap. So what exactly K will be equal to I cross J? Torque is again along which axis we consider K cap. So K is equal to what? I cross J. I is what? R cross F. So these are all in vector notations. लेकिन कौन सी direction में? Anti-clockwise. लेकिन motion का तो हो रहा particle X Y. Students, ये easy question मैंने पूछा था. अगर suppose मैंने YZ plane दे दिया होता तो तुम क्या करते? पगला के जाते ना फिर तो. फिर तुम सोचोगे तो बात अलग है ना. कि इतना स्ट्रेट फॉरवर्ड क्वेश्चन दिया था, ये सिखाने के बाद मैं वापस पूछ रहा हूँ, फिर भी नहीं आ रहा है. इसके पहले इसका डेरिवेशन भी लिया, फिर भी नहीं समझ रहा है. That means what exactly you've made of yourself? And I'm getting much more angry on this Gauri and Shreya. And Mihir, you also.
So actually, I knew the first, second, and third part, but when you said vector notation, I got confused. Like, what exactly we have to do? That's the reason I asked you to do the first part.
My dear, vector notation, that means I've given in terms of vector part. So vector notation, that means I wanted to find out the vector answer for this, and that is a vector product of the other. And these are all cross products. और सारों में कंपोनेंट क्या आएगा? एस को तुम लिखोगे तो कैसे लिखोगे? थीटा आर साइन थीटा या साइन अल्फा साइन फी. V is equal to omega cross r, so V is equal to omega r sin theta. Tangential alpha into r sin theta. LRP sin theta. Torque RF sin theta. ये सारे क्रॉस प्रोडक्ट्स है. कहाँ पे पढ़े हो तुम लोग? सर यू हैव लर्नड इट इन क्रॉस प्रोडक्ट ऑफ वेक्टर्स. Can I erase it, students?
Yes, sir.
Okay. So now, students, when you consider that as a body when performing circular motion, students. Okay, a body when performing circular motion, it has only one acceleration, students. We consider uniform circular motion, that is acceleration centripetal, students. Okay, so we'll be going for the formula for acceleration centripetal, students. Okay, so we'll go for derivation for acceleration centripetal, students. Okay. acceleration centripetal is radially inward acceleration. It is also called as acceleration radial. And its correct formula is negative omega square into r. We are trying to get an answer for the students. Now, how do you go about with the students? Please pay attention. Think as if a particle is performing circular motion, that is, it's performing UCM. Okay, a particle is performing uniform circular motion, and it's performing uniform motion, circular motion along the circumference of the circle. It's performing uniform circular motion along the circumference of the circle. This is the horizontal x-axis, and this is vertical y-axis, students. This is origin. Since the particle is performing circular motion, where is a position vector I'll consider? Since if the particle is performing uniform circular motion, let us say the particle is initially at point P, and it's forming an angle, students. It's forming an angle. Listen carefully. It's forming an angle theta with the horizontal. तो ये क्या हुआ? ये पोजीशन वेक्टर है. पार्टिकल परफॉर्म क्या कर रहा है? यूनिफॉर्म सर्कुलर मोशन. मुझे किसका फॉर्मूला चाहिए? मुझे सेंटीमीटर एक्सेलरेशन का फॉर्मूला चाहिए. सेंटीमीटर एक्सेलरेशन का फॉर्मूला क्या है? The acceleration which is directed from the particle towards the center, and its formula is negative omega square into r. I want to get that. So सबसे पहले what I'll do, students, I'll try to resolve. Students, listen carefully. I'll try to resolve r into two components, because when you look at the particle P, this particle P is performing circular motion and it has coordinates theta comma r. Students, इसको हम बोलते हैं polar coordinates. If I want to resolve r, I'll resolve r into two components: horizontal, vertical. यानी हम vectors पे जा रहे हैं. What is the horizontal component we consider? तुम बोलोगे सर it's rx. ये क्या होगा? सर ये ry होगा. rx क्या है? तुम बोलोगे सर r will be r cos theta I cap. ry क्या होगा? सर ये तो vectors है. r sin theta j cap. Can I use triangle law of vector addition to find out the answer for the resultant vector r? Why not? So students, r bar क्या होगा? Sir, r bar will be rx bar plus ry bar. So can I write on r bar as r cos theta I cap plus r sin theta j cap? And this answer is simply in in units. Let us say the position vector be in meter. ये distance है, students, ये distance है, so it can be meter, it can be in centimeter. लेकिन ये position है, distance of the particle. क्या इतना part clear हुआ सबसे पहले?
Yes, sir.
Yes, sir.
Yes.
These are simple vectors hai. I'll give you time to copy it down. Students, we are trying to go for the formula for acceleration centripetal. So consider how to go about it. Consider a particle P performing uniform circular motion along the circumference of the circle. By getting it at a particular instantaneous position, the particle is having coordinates theta comma r. The position vector is resolved into two components. It's r sin theta and r cos theta we consider. So r bar is equal to r cos theta I cap plus r sin theta j cap. मुझे क्या चाहिए, students? What do I need to find out? So, sir, you need to find out acceleration. What is happening, students, over here? Sir, in this case, the position of the particle goes on changing. Students, particle पहले यहाँ पे, ध्यान से देखो, students, particle यहाँ पे है. फिर कुछ टाइम के बाद particle यहाँ पे होगा. फिर कुछ टाइम के बाद particle यहाँ पे होगा, है ना?
Yes.
तो अगर particle यहाँ पे है, तो उसका ये है position vector. यानी अगर ये डायरेक्शन, डांस सुनना, अगर ये डायरेक्शन ऑफ पोजीशन वेक्टर चेंज हो रहा है विथ रिस्पेक्ट टू टाइम, if the direction of the position vector goes on changing with respect to time, can I say my direction of velocity is also changing?
Yes.
Yes, sir.
Can I differentiate both the sides with respect to time?
Yes, sir.
Yes.
तो यहाँ पे क्या होगा, स्टूडेंट्स? तो सर आप ये बोलना चाहते हो कि इसको डिफरेंशिएट करोगे, तो व्हाट इज एक्चुअली डिफरेंशिएटिंग? सर dr by dt. Agreed?
Yes.
And what is actually differentiating here? Differentiating this will be what? Differentiating r cos theta I cap. So what is differentiating r cos theta I cap? It is u plus v method. What is differentiating r cos theta I cap? Can anybody give me the answer for this? Students, differentiating both the sides. So dr by dt is equal to differentiating r cos theta. So I'll write down first this r cos theta I cap by dt plus differentiating r sin theta j cap by dt. क्या ये clear हुआ students?
Yes, sir.
Can anybody give the answer further?
Sir, R will be constant, no?
Of course, r will be constant.
So it will come outside then.
Very good, very good. And what exactly dr by dt will be v?
V
ये r तो बाहर आएगा.
minus sin
Differentiating
x.
cos theta. Very good. Minus sin theta. Into what?
I.
No, my dear. D theta by dt I cap.
Yes.
Students, ये होगा ना? Theta भी होगा ना? Differentiating theta भी होगा with respect to time. क्या ये क्लियर हुआ स्टूडेंट्स? ये कैलकुलस पे चला गया, जो कैलकुलस तुम पढ़ चुके हो. इज इट क्लियर?
Yes, sir.
Yes, sir.
What about differentiating r sin theta, students? Can I remove r common? What is differentiating sin theta?
Cos theta.
Cos theta into d theta by dt j cap. So now can I say v bar will be equal to minus r. Students, what is d theta by dt? Students, what is d theta by dt?
B.
Omega.
Yes, sir. Omega.
So can I put omega? Sin
Yes.
theta I cap plus r omega cos theta j cap, and this answer is in what? मीटर पर सेकेंड. अगर ये मैंने मीटर में दिया है तो ये आंसर किसमें होगा? मीटर पर सेकेंड होगा. आगे तुम्हारा वेलोसिटी. क्या ये क्लियर हुआ स्टूडेंट्स? ऑल ऑफ यू ऑल?
Yes, sir.
Yes, sir.
Yes, sir.
Gauri, what about you? Yes. Shreya and Mihir, three of them are responding. The rest of them, all of you all are keeping shut.
Yes, sir.
You all are not speaking at all. That shows ki what exactly is happening. Rakshita just now said it. Meenu is responding.
Yes,
Thank
sir.
you, Meenu. Thank
Understanding.
you.
Yes, understood.
Yes, sir, understood.
क्या बात है, अभी तो निकल पड़ी मेरी. आज का दिन बना दिया तुम लोगों ने. You made my day by responding more than 3 students. Okay, students. अभी आंसर दो प्लीज. ये ध्यान में रखना स्टूडेंट. कभी भी हम डिफरेंशिएट करते हैं ना स्टूडेंट, तो ये जो थीटा है उसको भी करना है डिफरेंशिएट. You have to differentiate theta also. Prapti. Okay, so what exactly is minus r omega sin theta I cap? I getting it? ये velocity मुझे क्या चाहिए? Acceleration. So differentiate velocity with respect to time. So can I say dv by dt?
Yes.
That will be equal to what? इसको भी differentiate करो students. So can I say r constant, omega constant क्योंकि motion UCM आया ना?
Yes, sir.
Yes, sir.
Further अगर मैंने लिया sin theta. Students, what is differentiating sin theta? Students, what is differentiating sin theta?
Cos theta.
Cos theta into d theta by dt upon I cap. Agreed?
Yes, sir.
Plus r omega. What is differentiating cos theta?
Minus sin theta.
Minus sin
Minus
theta.
sin theta into d theta by dt and d cap. क्या ये clear हुआ students?
Yes, sir.
Yes, sir.
This becomes your acceleration, rate of change of velocity. Agreed?
Yes.
Yes, sir.
Yes, sir.
Minus r omega. Is this d theta by dt is omega?
Yes, sir.
So can I put omega square cos theta I cap?
Yes, sir.
Agreed?
Yes, sir.
Plus into minus minus r What is d theta by dt? Omega. Omega into omega will be omega square.
Omega square.
Sin theta j cap.
J.
Clear हुआ?
Yes, sir.
Now can I write down negative sign outside, omega square outside bracket by, can I run r cos theta I cap plus r sin theta j cap?
Yes, sir.
But what is r cos theta I cap, r sin theta j cap is?
R.
Therefore, can I say acceleration? तो ये कौन सा acceleration होगा? Shouldn't ये कौन सा acceleration है? ये क्या है? फिर ये how do you come to that conclusion? ये r का मतलब क्या हुआ? सर ये r तो position vector है. Particle circular motion तो perform कर रहा है. क्या पार्टिकल सर्कुलर मोशन परफॉर्म कर रहा है? हाँ या ना?
Yes, sir.
कैसे प्रूव करोगे? कैसे प्रूव करोगे? कैसे प्रूव करोगे? सर आपने बोला कि जब भी सर्कुलर मोशन होगा तो v बार और r बार और r बार हमेशा परपेंडिकुलर होगा. हाँ या ना?
हाँ.
Yes,
हाँ या
sir.
ना? यानी उनका डॉट प्रोडक्ट का आंसर क्या आना चाहिए? मींस v बार और r बार का डॉट प्रोडक्ट क्या आना चाहिए? 0. आंसर 0 आना चाहिए. Do you have formula for v bar? See? Yes. Do you have formula for r bar? Yes.
Yes.
Chalo, do mental maths. Students, without writing it on a piece of paper, do mental maths and get me an answer of v dot r. Students, dot product के अंदर vectors में क्या पढ़ा तुम लोगों ने? I dot I का value क्या होता है? What is I dot I?
0.
1.
1.
1.
Both the vectors are in same direction. I dot I 1. J dot J
1.
1. K dot K
1.
1.
I dot J
0.
0.
K dot K
0.
0 and K dot I also 0. Agreed? Agreed?
Yes.
अभी मुझे
Yes,
सर्कुलर
sir.
मोशन, तो स्टूडेंट्स कैन आई प्रूव v डॉट r? यानी स्टूडेंट्स v में ये है, ये दो टर्म्स है, ये दो टर्म्स मल्टीप्लाई करो. स्टूडेंट्स अगर मैं इसको इससे मल्टीप्लाई करता हूं, प्लीज पे अटेंशन स्टूडेंट्स, आई एम डूइंग मेंटल मैथ्स, आई एम डेलिबरेटली नॉट राइटिंग इट, but those students who are good in calculus will be able to get it. Students, what is r omega sin theta I cap with this? तो क्या होगा सर? cos theta sin theta I into I will be 1
1.
का r square omega with negative sign, है ना?
हाँ.
ये क्या होगा सर? ये I है और J है, तो I dot J का आंसर क्या होगा? 0. Agreed?
Yes.
Now can I multiply this part? Multiply this part with this. What is J dot I?
0.
0.
J dot J
1.
1.
1. इसका आंसर क्या होगा? R square omega sin theta cos
Omega
theta.
sin.
लेकिन पॉजिटिव में आ रहा है. समझ में आ रहा है स्टूडेंट्स?
हाँ.
यानी एक आंसर मुझे मिल रहा है नेगेटिव में, sin theta cos theta नेगेटिव मिल रहा है, दूसरा मिल रहा है sin theta cos theta पॉजिटिव मिल रहा है. पूरा कैंसिल होके am I getting the answer 0?
Yes.
Yes.
सो स्टूडेंट्स, मैंने ये पूछा कि ये जब तुम फॉर्मूला देखते हो तो ये फॉर्मूला में ये एक्सेलरेशन कौन सा है? टैंजेंशियल हो ही नहीं सकता है, ये सेंट्रीपिटल ही होगा क्योंकि पाथ सर्कुलर है. अगर पाथ सर्कुलर वेक्टर है और ये पोजीशन वेक्टर r बार किस तरफ जाता है, ये नेगेटिव साइन क्या दिखाता है? व्हाट इज दिस नेगेटिव साइन शोज इन वेक्टर्स? दैट एक्सेलरेशन एंड पोजीशन वेक्टर आर इन ऑपोजिट डायरेक्शन. आर इन व्हाट डायरेक्शन? ऑपोजिट डायरेक्शन, एंटी पैरेलल. तो अगर ये रेडियस वेक्टर है तो ये तुम्हारा एक्सेलरेशन कौन सा होना चाहिए? सेंट्रीपेटल, क्योंकि ये नेगेटिव साइन बताता है कि ये दोनों ऑपोजिट डायरेक्शन में होता है. तो व्हाट इज द फॉर्मूला फॉर एक्सेलरेशन सेंट्रीपेटल? हाँ, क्या ये क्लियर हुआ?
Yes, sir.
Yes, sir.
Yes, sir.
Fine, copy down this. Everybody please copy down properly, yeah, students. Students, have you understood the proof, students? Students?
Yes, sir.
Yes, sir.
Students, really perpendicular, it's a circular path we consider. And secondly, your acceleration, centripetal students, and your position vector, दोनों opposite direction में होते हैं हमेशा. ये ध्यान में रखना students. तो formula for acceleration centripetal is negative omega square into r. Can I erase it, students?
No, sir.
Yes, sir.
Yes, sir.
So 1 minute.
Okay, fine, doesn't matter. Write down.
So done.
Okay, students. So students, today we'll be keeping it up till here. It's just last 15 minutes are left. We'll pick up in the next lecture, students, because I feel like that there is some issue with my net also. It's blinking in that case. Okay. So today we'll be finishing with your acceleration centripetal students. Okay, the derivation of W, and kindly revise this learning.
Yes,
Yes,
sir.
sir.
Lectures will be continued. So please repeat the formulas also. Next time we'll be solving the problem. So, okay, students.
Okay, sir.
Okay, sir.
Yes. Thank you, sir.
Bye,
Thank
sir.
you, sir.
Bye, sir.
Bye,
Thank you,
sir.
sir.
Bye, sir.
Thank you, sir.
Bye.